We recently watched a video on integer powers of 10, and so hopefully you remember this next slide that has to do with zero exponents. And we figured out by filling in this chart and continuing the patterns that anything to the 0 power was 1. So in these examples down at the bottom, 11 to the 0 power is 1. 735 to the 0 power is 1. 29 to the 0 power is 1. And 6.7 to the 0 power is 1. So we're just taking a moment to remind ourselves of this and go a little bit further. And of course, I know I just said anything to the power of 0 is 1. And now here I'm going to go and say the opposite of that. Sometimes it won't be 1, but it depends, just like something we did earlier this year with absolute value. So before I answer these two questions that are at the top of this page, I want to remind ourselves from earlier in the year when we talked about absolute value, we had an example like this, that the absolute value of -5, and I said, well, what comes out of absolute value will be positive because absolute value is something's distance to 0. So on a number line, if this is -5, it is 1, 2, 3, 4, 5 spaces away. So we said anything that comes out of the absolute value sign is going to be positive, but then I had to say that doesn't mean the answer to every absolute value question will be positive. And we saw this example. The negative absolute value. Well, what's going to come out of here will be a +5 because that's how far away -5 is from 0. But then this negative sign comes down to join it, and I end up with a -5. So with that in mind, I'm going to come up and look at these two questions that were at the top of this page. This first one that has parentheses is holding that negative onto the 8. And so it's saying -8 to the 0 power. And as I said before, anything to the 0 power is 1. If we look at this next one, it's just a little bit different. It doesn't have those parentheses holding the negative sign on. So what this is actually saying is 8 to the 0 power, which is 1. But then there's that negative in front of it, which turns my answer into a -1. So the way that this is written, -8 to the 0 power, that answer is -1. Because that negative gets added on at the very last chance, just like in this other problem we did earlier in the year, where the negative that was on the outside of the absolute value got added on at the end. Here we have a definition for negative exponent. On your notes page, you will see the star that tells you this is going to be a definition. And there's room for you on your note page to write down negative exponent is repeated division. And that should make sense to us because an exponent is repeated multiplication. And since negative means opposite, and the opposite of multiply is divide, then this makes sense. So here's what it's going to look like. X to the 5th. What does that actually mean? It means x times x times x times x times x, x to the 5th. I am repeatedly multiplying x by itself. So when I have a negative exponent, no, that doesn't mean just put a negative symbol on the answer. It's repeated division. So it's still going to be x times x times x times x times x, but it's going to be under the division line. This is repeated division. I know it looks like multiplication because of those multiplication dots that are in between there, but because it's under the division line, I'm actually taking 1 and I'm dividing it over and over again by all of these x's. So what would be an easier way to write this? 1 over x to the 5th. In other words, this becomes 1 over x to the fifth. Notice that in this answer there are no negative symbols. In your math book, we always learn a definition using numbers, or excuse me, using variables instead of numbers. So here's the algebraic definition of a negative exponent. You have room on your paper to write this down, and that is that any number to a negative exponent, so let's say 3 to the negative sixth, what will that look like? It will look like 1 over 3 to the sixth. Notice that in the answer, there are no negative symbols. What I did was take that 3 to the sixth, which really means 3 times 3 times 3 times 3 times 3 times 3. But because there was that negative symbol, I'm not doing repeated multiplication, I'm doing repeated division. So it was under the division line. What would be a much simpler way to write that? There it is. I've got 3 to the sixth, but it is on the bottom. It's being repeatedly divided. So here are some examples. Y to the negative 4. Well, that's y times y times y times y, except it's going to be underneath the division symbol, underneath the division line. What would be an easier way to write this? 1 over y to the fourth. What about 3 to the negative 2? Well, I'm going to skip that long way, this one right here. I'm not going to do that for this one because I think I'm kind of understanding this. I'm going to have 3 to the 2. It's just that it's on the bottom, and I'm supposed to put a 1 on the top. This is a good answer. I know that you guys could make this one step further. What is 3 to the second power? 3 times 3 is 9. And what about this last one, 2 to the negative third? Well, that's 2 to the third. It's just that it's on the bottom with a 1 on the top. And I know you could make this better. 1 over, let's see, 2 to the third. That means 2 times 2 times 2, which is 8. So that ends up being 1 over 8. Here are 3 questions for you to try. They show up on your notes page, so you can go ahead and take a moment to pause this video while you try these 3 questions. And then I want to think of another way to describe this. A negative exponent can also be thought of as a reciprocal. Now, reciprocal, I remember that from when I was learning to divide fractions. And I remember reciprocal meaning that if I multiply by the reciprocal, I would end up with a whole number 1. So on these problems, here's another way to think of a negative exponent as a reciprocal. What would the reciprocal of 5 over 6 be? 6 over 5. So if I do the reciprocal, that will take care of the negative. So it's not going to be to the negative second power anymore. Now it is to the second power. Now, why does that work? Let me jump back to these first problems. X to the fifth. How would I write x to the fifth as a fraction? X to the fifth over 1. Well, what would the reciprocal of x to the fifth over 1 be? What's the reciprocal of this? What's the reciprocal of this? It would be 1 over x to the fifth. That's the reciprocal. And look what I got. There it is. 1 over x to the fifth. This makes sense. It is the reciprocal. Let me look at some of these other problems. Let's see. 3 to the negative sixth. What would that look like? 1 over 3 to the sixth. That makes sense. Okay, I'm just flipping this over. 3 to the sixth over 1, what would the reciprocal be? it would be this. So that negative symbol there, another way we can think about a negative exponent is as a reciprocal. So with 1 over 3, what would the reciprocal of 1 over 3 be? Well, it would be 3 over 1. Now that I've done that, this exponent is no longer negative 3. It's going to be a positive 3. Well, what would that look like? 3 times 3 times 3, and 1 times 1 times 1. That's going to be 27 over 1, which is just 27. Let's go back to this last one so I can finish it. 6 to the second power over 5 to the second power. Those are both numbers I know you guys know. 6 to the second power, 6 times 6 is 36. 5 to the second power, 5 times 5, 25. Please remember that the best part about these videos is that you can pause them whenever you would like. You can go back and re-listen to any of those explanations before we move on. I have one final way for you to think about a negative exponent. A negative exponent can also be thought as the term with the negative exponent needs to be moved to the opposite location. Remember that negative means opposite. So the final way to think about this is like this. This piece has a negative exponent. I need to move it to the opposite location. If this was a fraction, it would be 13p to the negative 4 over 1. This piece with the negative exponent needs to be moved to the opposite location. Where is it right now? It's on the top. So where is the opposite location? It's on the bottom. When I move it to the opposite location, I've now made it positive, and everything else gets to stay where it was. So the 13 gets to remain on the top. On your note page, you'll see something that says Miss Carnes hates. And what you need to fill in, what do I hate? I hate negative exponents, negative exponents. So fix them. If you see a negative exponent, I want you to turn it positive. And here's one way to do that. By moving it to the opposite location. If it's on the top, like in this first problem, we moved it to the bottom. What do you think we'll do in this next problem? Where is the negative exponent? It's on the bottom. Where is the opposite of the bottom? Oh, it's on the top. So the c to the second is going to move up to the top, and that 5 gets to stay where it was. Well, what would be left on the bottom? Just a 1, reminding ourselves we can turn anything into a fraction by putting a denominator of 1. But you also know how lazy I am, so I'm just going to write 5c to the second. I just moved the parts that had the negative exponent to the opposite location. Here are 2 for you to try. I'm going to go ahead and circle what should be moved. This x to the negative 9 should be moved. The 11 and the 4 get to stay exactly where they are. Those 11 and 4 don't bother me because they didn't have a negative exponent. In this second problem, the r to the negative 5th is going to have to move to the opposite location because that negative exponent bothers me. The rest of it is fine.